Then for question 3, I'm given the following diagram on a Cartesian plane. It's a triangle on a Cartesian plane. So I'm given A, B, C, and their points, which are the vertices of the triangle, and I'm told that S is the midpoint of BC, so they've labeled that BS is equal in length to CS, and then I've got that this line AS is perpendicular to the line BC. And I'm asked a few questions. So the first, 3.1, is to calculate the coordinates of point S. So I was told that S is the midpoint of BC. So for this, I can just use the midpoint formula, which means that I'm going to add the x values of B and C and divide them by 2, which gives me the x value of S. And then I'm going to add the y values of B and C and divide them by 2, which is going to give me the y value of S. So I know that S is going to be the point where xb plus xc is divided by 2 and yb plus yc is divided by 2, and -7 plus 1 is -6 divided by 2 is -3, and then 1 minus 7 is -6 divided by 2 is also -3, and I can fill this in on my diagram. So S is the point -3, and this makes sense because S is below the x-axis, so I would expect the y value to be negative, and it's on the left of the y-axis, so I would expect the x value to be negative as well. Then the next part, 3.2, I'm asked to determine the gradient of the line AC, which is this line here, and I've got a straight line and I know both of the points on the line, so I know that the gradient is just going to be the rise over run, which is the same as saying that the gradient is the change in y over the change in x. So MAC means that I want the change in y over the change in x, and so that means I want y of A minus y of C divided by x of A minus x of C. So the y value of A is 5, and that is minus the y value of C, which is -7. And then the x value of A is 5 minus the x value of C, which is +1. Now this 5 minus -7 at the top is going to become positive, so I've got 5 plus 7, which is 12, and 5 minus 1 is 4, and so the gradient is just 3. Okay, then the next part asks me to find the distance of BC. That is this distance here. And I've got 2 points on a straight line, so I can use my distance formula. And the distance formula says that the distance of BC is equal to the square root of x of B minus x of C all squared plus y of B minus y of C all squared. So I'm just going to substitute in these values. So B was the point -7 for x, and C has +1, so I've got minus +1 for the x of C squared, plus y of B was 1, and minus the y of C, which was -7 squared. So the first bracket, I'm going to have -7 minus 1, which is -8 squared, plus the second bracket, 1 minus -7, those two minuses become positive. So I've got 1 plus 7, which is 8 squared. And then I've got 64 plus 64, which is 128, square rooted, and I can simplify that to be 8 root 2. And then the final part of question 3 is 3.4. And for that, I'm asked to determine the area of ABC. So I want to find the ABC, the area of this triangle ABC. And lucky for me, I was given this line AC, and I was told that it's perpendicular. So AS is perpendicular to BC. So since I have that this is perpendicular, I can use that the area of a triangle is half base times height. So the height is going to be the distance of these 2 points A and C, and I've already found the distance of BC. So I'm just going to have half of this number, which was 8 root 2, and I'm going to find, excuse me, the distance AS. Multiplied together divided by 2 is going to give me the area of the triangle. So I can say that area ABC equals half base times height. And in this one, my base is BC, and my height, perpendicular height, is AS. So I need to first find DAS, and I'm going to use the distance formula again. So this is going to be x of A minus x of S squared plus y of A minus y of S squared. And I'm going to substitute in the points. So x of A was 5 minus the x of S we found was minus 3 all squared, and then y of A is also 5 minus the y of S, which was also negative 3 all squared. And this is going to give me 8 squared plus 8 squared, which is 64 plus 64 and 128 again. I'm going to keep this as square root 128, and I'm going to rewrite this bit. And now I can substitute in these values. So I've got half BC. This was also root 128. And this one is root 128. So these square roots times each other is just going to cancel out the square roots. And so I'm just going to have 128 over 2, which is 64. And they didn't give us units, so I'm going to say units squared because we're talking about area. Moving on to question 7, I'm given this diagram, and I'm told that RSTQ is a parallelogram, and RS is parallel to QT, and QR is parallel to TS. And I'm told that VQ, this one, bisects this angle RQT, and that VT bisects this angle Q to S. So they've labeled it for me that X is equal to X here and Y is equal to Y here. Okay, and then we have some questions. So the first question is to prove that angle V2 is equal to 90 degrees. That is this one. Okay, so the first thing that I'm going to do is look at my parallel lines, so I know that these two are parallel. And from parallel lines, I know that co-interior angles add up to 180 degrees, so that would mean that this whole angle Q plus this whole angle T is going to be equal to 180. So I'm going to say that angle Q plus angle T equals 180 degrees, and the reason is co-int angles QR parallel to ST. And I know the value of this angle. This is x plus x, which is 2x, and I know the value of this angle, which is y plus y, so it's 2y. So that means that 2x plus 2y is equal to 180 degrees because of this co-interior. And then I can just divide everything by 2. So I've got that x plus y is equal to 90 degrees. So now I've got the values x and y that are added together equal 90 degrees. And the final thing that I'm looking for, V2, is a part of this triangle. This triangle here. So I already know what these two sum up to. And I know that if I add this one, it's going to have to equal 180 degrees because that's my angles in a triangle. So I'm going to have that x plus y plus angle V2 equals 180 degrees, and that is angles in triangle VQT. And I've already said above that x plus y is equal to 90, so that means that 90 degrees plus V2 equals 180 degrees. Therefore, V2 is equal to 90 degrees. Okay, and then for the next part of question 7, that's 7.2, I'm asked to prove that RS is equal to 2RQ, so that this one is equal to 2 of these. Okay, so going back to my original information, I was told that RSTQ is a parallelogram with these parallel sides. So I have these parallel sides and I've got some lines joining them. So from these two being parallel and this line in between, I know that this angle here is equal to this angle here, and that's because of alternate angles with parallel sides. So if that one is equal to x, then this one is also equal to x. V1 is equal to x. Okay, so then if V1 is equal to x, and I was told that Q1 is also equal to x, then I've got these angles being equal, and then I know that this line must be equal to this line because of equal angles under opposite sides. So I'm first going to write that angle V1 is equal to x, and that's alt angles RS parallel to QT. Therefore, angle V1 is equal to angle Q1. Then I can say, therefore, the line RV is equal to the line QR, and that's because of equal angles under opposite sides. So I found that this line is equal to this line. Okay, then I can do the same thing on the other side. So I can say that angle V3 is equal to angle T1, again because of alternate angles, and this time I'm using the same parallel lines, but I'm using this line in between them. So this angle is going to be equal to this angle, which means that V3 is equal to y. That's T1. So I'm going to say that angle V3 is equal to angle T1 is equal to y. And that's because of alt angles, again RS parallel to QT. And then I can do the same thing. I can conclude that this line is equal to this line because of equal angles under opposite sides. So therefore, first I'm going to say that V3 is equal to T2. And then I can say that ST is equal to SV. Okay, so I've got this line that these two are equal and that these two are equal. But I also know that these two are equal because I was told that it's a parallelogram. So I know that QR is equal to ST, and I was given that. And that is opposites palm. And remember that the question was asking me to prove that RS is equal to 2RQ. So this is RS, and RS is made up of RV and of VS. So if RV and RS are the same length as QR, then this one and this one together make up RS, and that is equal to 2 times Q of R. So I've got one Q of R with VR, and then with VS I have another Q of R, they're the same length. So that means that 2 of this length is equal to 1 of this length. So I'm going to start by saying that VS is equal to RQ is equal to RV. Therefore, RS is equal to 2RQ. Okay, then question 8, we're given a triangle ABC with these midpoints M and N of AB and AC respectively, and we're asked to prove the theorem that states that MN is parallel to BC. So I'm going to prove this by using the congruency of triangles. So the first thing that I'm going to do is construct a triangle here on the outside of this triangle by placing a point P. And I'm going to make it such that NP is equal in length to MN. Okay, so the first thing about these triangles is that I've got two angles. I've got this, I'm going to call N1, and this one is N2. And these are equal to each other because of vertically opposite angles. And then I've also got, by construction, that NP is equal in length to MN. And then I was given that NC is equal to AN because NC is the midpoint. So from that I have side angle side, and I can say that this triangle is congruent to this triangle. So first I'm going to say construct triangle NPC such that NP equals MN. Then I can say that angle N1 is equal to angle N2, and that is from vertically opposite angles. And then I can say that NC is equal to AN, and that was given. Therefore, triangle AMN is congruent to triangle PNC. Okay, then from the congruency, I can say that this side here, PC, is going to be equal to this side, MA, and that is from congruency, congruent triangles. All right, and then I also have that this side MN is equal to CP, because I was given that MA is equal to BM, again that M was the midpoint, and I also have that MP is equal in length to BC. So I'm going to say MP equals BC and MB equals PC. So if I've got this side equal to this side and this side equal to this side, then that means that I've got a parallelogram. So this one, BCPM, is my parallelogram. And that's because of opposite sides equal. And therefore, I can say that these opposite sides, MN and BC, are parallel. And that reason is palm. So upsides parallel in palm BCPM. Okay, and now the final part of question 8, this is 8.2. I'm given this triangle PQR, and I'm told some information, so I know that QT is going to be equal to UT, and I know that QS is equal to SR, and I'm told that this length UV is equal to X. So if QT is equal in length to TU, then that means that T is a midpoint. And similarly, if QS is equal to SR, then that means this S is a midpoint. And I'm thinking midpoint, 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 so I can use my midpoint theorem. And indeed, I've got this line, TS, that is joining two sides of the triangle at the midpoints S and T, which means that this third side of the triangle is going to be parallel to this line TS, and it also means that this side UR is going to be twice the length of this line TS that's joining the midpoints. So I can first say that TS is parallel to UR, and that is because midpoint theorem. And for the same reason, I can say that UR is equal to 2 times TS, midpoint theorem again. So now that I know that TS and UR are parallel, then that means that TS and UV are also parallel. And since this UV is going through another midpoint U is now the midpoint of TP, then that means that V must be a midpoint, and it means that this UV must be half of the length of TS. So UV is equal to 2TS, and that's from the converse midpoint theorem. So let's label that as well. So now I've got U, which is the midpoint of these two, the UP and the TU. And so again, I found that these are parallel. So if TS is parallel to UV, and UV is a line that joins a midpoint on one side of a triangle and it's going to the opposite side of the triangle, then that means that V is a midpoint. And then from the midpoint theorem, or the converse midpoint theorem, I can conclude that UV is equal to twice the length of TS. Sorry, that TS is equal to twice the length of UV, which is 2x. So from the converse midpoint theorem, I can see that TS is equal to 2UV is equal to 2x, and that reason is converse. Converse midpoint theorem. So now I know that TS is equal to 2x, and I had said that 2TS is equal to UR, which is this whole line here, which means that UR is equal to 2 times 2x, right? So if UR was equal to 2TS and TS is equal to 2x, then UR is equal to 2 times 2x, which is 4x, right? So that's for the whole line UR, but I was given that UV is equal to x. So that means that VR is going to be equal to the whole of UR, which is 4x, minus just this 1x, and so VR is equal to 3x. So I will say that UV is equal to x, and that was given. Therefore, VR is equal to UR minus UV, 4x minus x is equal to 3x, and that's what we were asked to find.